Hello everyone. Now we are going to learn something about energy storage devices. Energy storage devices are technologies that stores energy for later use and enabling efficient and reliable energy supply. Some examples for energy storage devices are batteries, capacitors, supercapacitors, flywheels, etc. Now we are going to see in detail about battery. A battery is an arrangement of several electrochemical cells connected in series that can be used as a source of direct electric current. A cell contains only one anode and one cathode, but a battery contains several anodes and several cathodes. Requirements of a battery. A useful battery should fulfill the following requirements. It should be light and compact for easy transportation, and it should have longer lifetime both when it is being used and when it is not used. The voltage of the battery should not vary appreciably during its usage. Next, types of battery. There are three types of battery. The first one is primary battery, otherwise called as primary cells, in other words, non-reversible battery. In these cells, the electrode and electrode reactions cannot be reversed by passing an external electric current. The reactions occur only once and after use they become dead. Therefore, they are not chargeable. Example for primary battery are dry cell, mercury cell. The second type is secondary battery, also called as secondary cells or reversible battery. In these cells, the electrode reactions can be reversed by passing an external electrical energy. Therefore, they can be recharged by passing electric current and can be used again and again. These are also called storage cells or accumulators. Example for secondary battery is lead acid storage cell, nickel cadmium cell. The third type is flow battery, otherwise called as fuel cells. In these cells, the reactants, products, and electrolytes are continuously passing through the cell. Here, chemical energy is converted into electrical energy. Example for fuel cell is hydrogen oxygen fuel cell. Now we are going to discuss in detail about lead acid storage cell or lead accumulator. Introduction. It is a secondary battery which can operate both as a voltaic cell and as an electrolytic cell. When it acts as a voltaic cell, it supplies electrical energy and becomes run down. When it is recharged, the cell operates as an electrolytic cell. This is the schematic diagram of lead storage cell. See, in this diagram, anodes or lead plates are connected in series and is taken as anode. Similarly, lead oxide plates are connected in series and is taken as cathode. Both anode and cathode is immersed in an aqueous solution, that is dilute sulfuric acid. This is the setup of lead acid storage battery. Description: a lead acid storage battery consists of a number of voltaic cells connected in series to get 6 to 12 volts battery. In each cell, the anode is made up of lead, the cathode is made up of lead dioxide, or a grid made up of lead packed with lead oxide. A number of lead plates are connected in parallel, and a number of lead oxide plates, that is taken as cathodes, are also connected in parallel. Various plates are separated from the adjacent ones by insulators like rubber or glass fiber. The entire combinations is then immersed in dilute sulfuric acid having a density of 1.30 gram per milliliter. This is the cell representation: lead slash lead sulfate, that is anode part, then double slash H2SO4 aqueous. This indicates the electrolyte, and then slash lead dioxide slash lead. This indicates the cathode part. So the cell representation indicates anode and electrolyte and cathode. Working, discharging, that means we are using, it supplies electrical energy. When the lead acid storage battery operates, the following reactions occurs. At anode, lead is oxidized to lead 2 plus ions, which further combines with sulfate ions, forms insoluble lead sulfate as shown in the reaction below. Lead combines with sulfate ion, gives lead sulfate plus 2 electrons. Here the arrow is double arrow, which indicates both forward and backward reactions takes place. At cathode, lead oxide is reduced to lead 2 plus ions, which further combines with sulfate ions, forms insoluble lead sulfate. Here is the reaction: lead oxide plus 4H plus SO4 2 minus plus electrons gives lead sulfate plus H2O. Here also the arrow is double arrow. Here also both forward and backward reaction takes place. The overall cell reaction during its usage: lead plus lead oxide plus sulfuric acid gives 2 lead sulfate plus 2 water molecules plus energy. Here also the arrow is double arrow. Both forward and backward reactions takes place. From the above cell reactions, it is clear that lead sulfate is precipitated at both the electrodes and sulfuric acid is used up. As a result, the concentration of sulfuric acid decreases, and hence the density of sulfuric acid falls below 1.2 gram per milliliter. So the battery needs recharging. How to recharge the battery? Let us see. The cell can be charged by passing electric current in the opposite direction. The electrode reaction gets reversed. As a result, lead is deposited on anode and lead oxide on the cathode. The density of sulfuric acid also increases. Here is the chemical reaction. Lead sulfate, water molecule plus electrical energy gives lead anode, lead oxide cathode plus sulfuric acid electrolyte. We are getting the chemicals back for further reaction. Then coming to the advantages of lead acid storage battery, it is made easily. It produces very high current and the self discharging rate is very low when compared to other rechargeable batteries. It also acts effectively at low temperature. Then disadvantages. Recycling of this battery causes environmental hazards because we are using lead metal here. Lead is a heavy metal and it pollutes the environment. And mechanical strain and normal pumping reduces battery capacity. Uses. It is used to supply current mainly in automobiles such as cars, buses, trucks, etc. and also used in gas engine ignition, telephone exchanges, hospitals, and power stations, etc. That's all about lead acid storage battery. Thank you.